Hello guys, now we will see about magnetic crane. Firstly, the things required for making a magnetic crane. Enamel copper wire. This is the enameled copper wire. Then the iron core. We have used iron bolt as a iron core. Now the voltage sources, that is the battery. Here we are used the 9-volt battery. Then the procedure, we are going to wound a copper wire on the iron core. This we have wound the enameled copper wire on the iron core, that is the iron bolt, and take care that the end leads of the iron of the copper wire are available for connecting to the batteries. Now after doing winding of the copper wire on the bolt, you have to burn the end leads because copper wire has the coating of insulation. So if we burn that, then we can get the copper wire and we can use that for the conduction. Then working principle. Magnetic crane works on the electromagnetism. Whenever there is current in the conductor, magnetic field is generated near the conductor. The direction of current and magnetic field can be determined by the right hand and thumb rule. Okay. Now we will see how it actually works. Connect the inlets to the battery, and now it will pick the iron material, and we can carry iron material from one place to another. Now we will see some theoretical part of that. This is the circuit diagram of our project. This is the solenoid at the rightmost side, and we have used 9-volt 3 batteries here. If we calculate the resistance of the solenoid we have used, it will be 3 ohm, and we are using battery of 9-volt each. So current from solenoid will be 3 ampere. If we want to increase the current in the conductor, then we should connect the 9-volt batteries in the parallel instead of connecting them in the series. If we connect all the batteries in series, then the total current we get from each battery will be the 9 ampere. And if we connect them in parallel, then current through each battery will be of 3 ampere, and our battery is of 1.5 ampere hour. So if 9 ampere current flows through battery, then it will discharge in 10 minutes only. If we use 3 batteries in parallel, then the current will be 3 ampere through each battery, and the time will be extended to 30 minutes. Here, why we need to increase the current is because MMF, that is magnetomotive force, is equal to N into I. N is the number of turns of the conductor, I is the current through conductor. So for increasing the force we need to increase the current, and in this above circuit voltage will be the constant. So V is equal to constant, I is equal to V by R, and we know R is equal to rho L by A. So mmf is directly proportional to area of conductor and inversely of current, length of conductor. So we have to use a conductor of lower gauge, and we also know that reluctance of magnetic magnetic path is directly proportional to the area of cross section of core and inversely proportional to the magnetic path. So we should use the core of big area of cross section, and it should be less in the length. Hence we can make a magnetic crane, a simple model of magnetic crane, electromagnetic crane.